In this video, we'll be solving linear equations in one variable. We'll look at two examples. The first example says, solve for x, and we're given this equation, 8x minus 11 equals 2x plus 7. So what does it mean to solve for x? It means find all x's that when you plug the x in, or the number that stands for x, into the equation, both sides will be equal to each other. So some number where you plug it in here and you plug it in here and both sides are in fact equal. Now, what's our general strategy for solving equations of this type? Well, what we're going to want to do is we're going to want to isolate the x. In other words, we want to try to get x on one side of the equation all by itself and then a number on the other side. How do we do that? We do that through using algebra. In other words, we're going to try to manipulate this equation with algebra until we have just a single x on one side and it's equal to a number. Now, how do we get a single x on one side? Notice that in this equation, we have an 8x on the left and a 2x on the right. In other words, we have x's on both sides of the equation. I'm going to try to make it so that there's only x's on one side of the equation. How do I do that? Well, if I have a 2x here, I can make it so there's not a 2x there by subtracting 2x. But we have this rule in algebra that says what you do to one side, you have to also do to the other side if you want them to still be equal. In other words, if this thing is equal to this thing, they'll still be equal to each other if we take away 2x from both of the sides. So if we take away 2x from the right, we also should take away 2x from the left, and then both sides will still be equal. So if I do 8x minus 2x, I get 6x, since 8 minus 2 is 6. I still have the minus 11 on the left. But now on the right, when I do 2x minus 2x, they cancel each other out, and I'm just left with no x's at all, and I only have a 7 on the right. So what you subtract from one side, you also have to subtract from the other. At this point, we have a 6x minus 11 on the left, and a 7 on the right. I want to try to make it so I only have a single x over here. This negative 11, that kind of is like getting in the way. So is this 6. How can I make it so this negative 11 is not here? I can actually add 11, and then the 11s will cancel out. I'll have negative 11 plus 11 is 0, so there will be just like no minus 11 on the left. But remember, what I do to one side, I have to also do to the other. So if I want to add 11 to the left, I also have to add 11 to the right. And then if I do that, the minus 11 plus 11 cancel out to give you no 11 on the left anymore. We just have a 6x. And then on the right, I have 7 plus 11, which is 18. So what have I done here? I've used a property of algebra that says I can subtract the same thing from both sides of an equation, or I can add the same thing to both sides of an equation, and we will still have both sides are equal to each other. They'll like have the same weight, I like to think of it as. Okay, now at this point we have 6 times x equals 18, and we want to just have x equals something. So there's this other property of algebra that says that if you have two sides of an equation are equal, you can actually divide both sides by the same thing. So what I'm going to do is I'm going to divide by 6 on both sides. I can't just do it on one side, because if I just do it on one side, they won't have equal weight anymore. You have to keep them equal by dividing it on both sides. So how do I divide both sides? What I do is I go divided by 6 and divided by 6. And if I do that, what I have is 6 divided by 6 is just 1. And so on the left, I end up with 1 times x. And then 18 divided by 6 on the right is 3. So I end up getting x is equal to 3. Now, this number that I get, x equals 3, it's the solution to the equation that we started out with. We call that the solution to the equation. Now, just as a tip, you can actually check your answer. So to check that this is the correct answer, we can take this number that we got and we can actually plug it into the original equation, which is 8x minus 11 equals 2x plus 7. And what are we looking for to make sure this answer is correct? We're looking for both sides of this to be actually like equal to each other when we plug 3 into the x spot. So we want to know, do we get both sides are equal when we plug 3 into this spot for the x? So 3 in here. Do we get this side is in fact equal to that side? So what I'm going to do is I'm just going to check really quickly that that is true. So 8 times 3 is 24 minus 11. Is that equal to 6 plus 7? So let's see, 24 minus 11 is, 13. And 6 plus 7 is also 13. So that means that our answer is in fact correct. Now, if you had gotten like two different numbers here, like 12 equals 13, that means you made a mistake in your work and you have to go back and try to figure out where your mistake is. Okay, that's example 1. Let's look at example 2. This one looks slightly more complicated because we have some parentheses thrown in here. So it looks a little bit more crazy than the last one that we did. But we're going to take the same general strategy. So the strategy is try to get x on one side by itself. Now, if you ever have parentheses, I would suggest that you first distribute things out. So distribute out so that there's no more parentheses anymore before you try to solve. So what do we get if we distribute the minus 3? We get negative 3 times x, and then we get negative 3 times negative 5. So I'm doing negative 3 times x and negative 3 times negative 5. And then we still have a minus 7. On the right, if I do negative 2 times x, I get negative 2 times x. And then if I do negative 2 times negative 6, I get negative 2 times negative 6. So I'm going to go through and I'm going to actually multiply these numbers that I wrote here. So negative 3 times x is just negative 3x. Negative 3 times negative 5 is plus 15 because a minus times a minus is a positive. So it's a similar thing on the right. Minus 2 times minus 6, or this minus 2 times minus 6 gives you a positive 12 because negative times a negative is a positive. Okay, now at this point we have a problem similar to example 1. What should we do? We can combine any like terms that we see on the right and left. So notice that right here we have a 15 and a 7. These are considered like terms because they're both constants, and so I can combine them. 15 minus 7 is 8. I don't see any like terms on the right, so I have a constant term and a term with an x, so nothing I can combine. Okay, now where do we go from here? I'm going to get all the x's on one side and all the constants on another side. So I can do that by either adding 2x to both sides or adding 3x to both sides. Perhaps this time I'll start with the bigger number, so I'm going to do plus 3x here and plus 3x here. Now if I do that, I get 8 equals 3x minus 2x is just one single x, and I still have the plus 12. Now usually instead of writing 1x, we would just write x. You don't really need to write the 1 in front of it. Okay, we want x all by itself, right? So how do we do that? We don't want to have this pesky 12 on this other side here. We don't want that 12 in the way. So I'm going to subtract the 12 from both sides to get x is equal to whatever 8 minus 12 is, and that's negative 4. Okay, so our answer is x equals negative 4. If we wanted, we could check this answer by plugging negative 4 back into the original equation up here. So if I want to check my answer, I plug it into this spot, negative 4, and I make sure both sides are equal to each other.